to anyone who watches this. So I've been thinking since my last learning stream, which was almost a month ago, about what to do next. It's longer than I had hoped. Since I did it, I was hoping to do them more frequently, but I got sick afterwards, and watching or listening to me cough for like a 3-hour stream is probably not going to be a good time. So I got to thinking what would be handy for most people, or at least for beginners right off the bat. Anyone can watch, and it'll be shorter than the last stream, which was 2 hours. This might be wrapped up in half an hour or so, I'm not sure. It could be really quick, but I'm going to give it a shot and see how it goes. Basically, version control. Okay, also I have a murderous cat who's messing with all of my things. So if my camera is, yes, okay, now focused directly on my forehead. No, cat, why now? Obviously, come back. Okay, she'll probably be right back, so that's going to be this stream's challenge. Last time my keyboard was malfunctioning, although at least I figured that out. Now I have, oh well, cat. Okay, anyway, sorry, I'm rambling already, so this is obviously going to go on longer than planned. But yes, this is a short 101 stream about version control and software engineering. So let's jump in. To start, what is version control? There have been several different version control softwares over the years that I've worked in, and there are, I'm sure, more that I haven't. When I began working, it was CVS or SVM. They're basically the same. And then after a little while, Git came out, and Mercurial, which are two that are sort of modern ones that I'm aware of. I've worked with Mercurial at one previous job, but most places use Git. And to be fair, like, they're functionally the same thing. The cat is back. Fantastic. Okay. She's wild. This bodes well. Alright. Let's just adjust this slightly. Cool. By version controlled software, I mean it allows you to maintain different versions of your code base. It allows for collaboration between teammates without overriding each other's work. That's sort of the main thing. It lets you and anyone in your team pull your code, your most recent changes. It allows work to be merged in, different active branches to exist, and yeah. If you're unsure of the value that provides immediately, then hopefully by the time I'm done with this video or stream, and then I will slap it on YouTube, you will agree that sort of it's quite indispensable. I've worked not on the team, but in a company with two other teams that didn't use version control. There was a PHP team, and what was the other one? I can't remember off the top of my head now. But they basically just had the team lead with the most recent version of everything, and when they needed new work done, someone would copy the project from him, the most recent project, work on a file and give it back to him, and he'd just override it. And they lost a huge amount of work to this way of doing things. Okay, cat, off you get. And eventually the CIO had to help them on a project, and he lost work, and he raged at them, and they jumped on Git. So yeah, basically I think Git is inevitable, or not Git necessarily, but version control. It's indispensable. You can't be a software engineer and not use it. Additionally, I've worked with people who come straight out of college and they have no idea what it is. So this is sort of aimed at those people. Although hopefully anyone can learn a little bit, or at least read it. But the point is, if you're looking at a software related job, even if like you're not a dev, if you're a QA or a tester or a designer or a product, delivery manager. This is the cat, by the way. Okay, the camera's now like looking at the roof, so that's fantastic. She had just got a case of the zoomies and has decided to annihilate everything, but especially the camera. Okay, so that's a vague and rambly introduction to what Git is. It allows you to store your code up in a cloud, which is a term that people like to throw around. It allows multiple working versions of your code, which I'll elaborate on later when I get into branches. It handles teams of people working on the same code base without overriding each other's work and resolving conflicts that may come up in that regard, which I'll also show. And I think that's sort of the main thing. So let's get started right off the bat. Your code is stored in a repository. A repository can have multiple branches, and I'll get into the branches just now. In my last video, we made a new repository to learn a bit of Spring. I'm not going to go into creating a new repository here because it's as simple as repository is new, and I want to have a little bit of code to work with. So I did this on the last learning video. I don't feel the need to repeat that because this is like creating an empty folder basically. Okay, cat. Cool. So this is the project that we built up last time. It's a very, very, very basic Spring Boot project. So I'm going to use it as my base. You can see here there's one branch. Okay, cat just pressed the button. That is the main branch. Normally, I think it's master. I'm not sure why GitHub called this main. I don't know if that's the standard, but typically your main branch is called master, but it's not super relevant. We're going to just use main here. Then, on a side note, a lot of people like using GUI apps for Git. There's a bunch. Tower, I think GitHub has their own GUI software. I like to use the command line, so that's what I'll be using for this evening. If you know how the command line works, you can use the GUI software. So that's, yeah, I think that's how you should start, to be honest. All right. So what we want to do, we have this repository up on GitHub. We want to get it locally so that we can make changes to it and push them back. So that's called cloning. What you want to do is you want to clone the repo. So that makes a local copy on your PC. So an easy way to just start is Bitbucket, and then they'll have basically there's a link to the repo on wherever it is, Bitbucket or GitHub or whatever. You want to just copy that. Then, okay, and here's the folder. So here on my coding Java Spring, the folder is currently empty. We're going to do a git load with the link that we copied. And this is going to clone this repo to be here on my PC locally. It's not a very big project, so it should clone pretty quickly. There we go. So now here we have cloned the repository and we have it on my PC. I'm going to work in Visual Code. Thank you. Okay. We're going to use code. We're going to make a minor change, and then I'm going to commit and push that so that you can see the very basics. If code would like to open. While that's busy sorting itself out, two very important commands that you use just to sanity check, or I use to sanity check myself all the time. Git status. So, alright, this is pretty standard. I just cloned the repo into Spring, but I'm not typing from the clone repo. So we must just change to Spring Note Taker. We're now in a Git repository. So if we take Git status now, so you see before it said fatal, this is not a Git repository because we were here, which is not a Git repo. But if we cd into Note Taker, and then we do a git command, we are now in a Git repository. It says you're on main branch, you're up to date with origin main, that means the one up in the sky, and nothing to commit, so we haven't changed anything. Is code going to open for me, please? Code. Hello. Thank you. Holy shit. Close. Alright. That took its time. It's still taking its time. Possibly because it deleted the project that it had open previously. Okay, good. Well, that's hopefully figuring itself out. The other command that is good for a sanity check is git branch. So this will show you the branch that you're on and list any other branches that you have locally. At the moment, it's just the one. But as we go through this, you'll see more and what that means. Right. Let us open a folder. I see a lot of IDEs these days have built-in Git support, so this actually lets you just straight up clone a repo. But I'm not gonna. Not all of them do that, and if they do, it might be handled differently in each one. So I'm not gonna go into that. Java, Spring Note Taker. Meowing cat. Hey, relax. Yes, I trust the authors. They were me. Cool. So let's open a terminal. Let's open in source. Main Java. Okay, so here. Hey, no! She climbed up my leg. Her claws are sharp. Okay, we have a model for our notes. And in our controller, I think I can. Okay, cool. And then this is the node controller, which handles. We don't need any Java knowledge for the course for this video, but I'm just using this as the base. So this is a class that handles requests to display, update, create, or delete nodes, and the note model is just like the database object for a node or nodes. Well, one node, but yeah. Okay, just to test that everything's working, we can do a. Please, I've got to remember this. Run. I don't remember if that's the command. Okay. Okay, cat. Oh my god. My arm is currently being mauled right now. Bring boot. Run. This is very professional. I should have remembered. I should have checked this command before doing anything. Let's just do a quick Google. Run Maven Spring Boot. Please don't eat my mouse pad. Okay. Oh my word. She's actually eating my hand. This... Is this not what I just typed? Hey! Stop it! Gosh. She's been so nice recently. And now that we have some attention... Is this different to what I pasted? Oh. I'm an idiot. And I used the wrong slash. Don't. Okay. This is my standard level of professionalism. There always has to be some wild distraction. Okay, so started application note taker. Fantastic. So what we okay, bite my ear. What we just saw was me forgetting a command, but also I cloned the repo from the cloud and I checked which branch we were on and the status of the repository. I opened up the project in code. I didn't change anything, and it ran. And we can now test it. Kitty, what are you after? So we can test that it works using our Postman test commands that we created last time. If we do get notes now, this should return an empty list. Of course, what it really does is just lag for a very long time. Okay, there. It's just got something. Yeah. So here we have an empty list. If we post a note, what are we going to post? Test title, blah, blah, blah. It returns with its ID. And if we run get note now, we should, there we go. Alright, so it's running locally and it's working. That's great. So let's stop it. Yeah. Cool. Anyway, we're not here to mess around with Spring. We're here to learn some Git. So we have now successfully cloned a repo. Let's look at what we might have to do next. Let's do a very, very minor change. Commit and push it and check that it reflects if we look online. So let's just do a git status for sanity again. You can see our branch is up to date with the origin and there's nothing to commit. So I can open anything. Let's add a comment. This is a default constructor for note models. Okay. This isn't a functional, change, but it makes no difference whether you're adding a comment or you're adding code, because essentially you're making changes to the file. So now, if we do a git status, we can see changes not staged for commit. So we made changes to Node.java, and they aren't really, well, we haven't staged them for committing. What committing means is when you commit files, they are then sort of stored locally as ready to push. And usually what you'll do is you'll commit when code is working, and then maybe at logical intervals you'll push. So committing doesn't actually send anything through to the server. It's reversible, but it is stored locally. And when you push it, that's when you send it through to the server and other people can put your changes. So also, just another on a side note, you can do a git diff and it'll show you where in the files your changes are. So here, we added this comment. So now let's commit this. Git commit am. So a is just all the files that are here. If there are new files, you might have to add them separately. They might not be included in the a. And m is for message. So you must always add a commit message. It's something short and relevant to what you did. So added a comment on the note structure. Okay. So now our change is local. We're one commit ahead of the master of the main branch, but we haven't pushed anything live. So let's do a git push. Compressed, pushed to remote. So now, if we refresh here, the source was updated 30 seconds ago. Can we look at the commits? I don't know what actions actually does here. Nope. Sorry about that. But if we go to our, oh, there, so we just click the comment there. Oh, yes, you could also see added comments to the constructor. See, these files were updated on different commits, so there's different comments there. And here, so it shows our one change in our commit. We added a comment, and this is what changed. Cool. That is, at its most basic level, Git. What you want to do the whole time as well is pull to make sure that you're up to date with changes on the server. The issue then is if you and someone else are working on the same branch and you pull their code, you've got to commit your code first, and then you can get merge conflicts and all kinds of issues. So that's where branches come in, working on different branches, merging the other people's branches into yours, and then merging your branches back into active branches. That I'm going to go into shortly. On a small side note, before I... No, okay, never mind. No side notes. Let's jump in. I've already been rambling for 20 minutes and accomplished almost nothing. I've done a good push. Now that we have our working project locally, let's look at how branches work and then dive into a small practical example. All right, you all know, because I've said several times, that I'm working on the main branch. What does that mean? I'd like to break out paint. And see if this can help me. Let's go across. So, in a line, this is our main branch. Let's do a text. Main. Which honestly is generally referred to as master, but whatever. The purpose of branches, well, there's several purposes of branches, but a good one is to avoid merge conflicts, as in overriding other people's work. Keep an up-to-date version of the code that you can pretty reliably know is always running, and yeah, because you don't want to commit code that like has compile errors or known issues. So you can test your branch and then merge it in to master in that way, or main, and that way always have a working main or master branch. So, say what you'll usually have, and this could be broken up by releases, say you release once a month, or you release every other month, or maybe you have a develop branch that you work on. I'm actually a fan of that one. So let's say what we do is, oops, we have a develop. I'm going to show you now how this all works. This way, no individual person works off main. We make another branch, we call it develop. This is every company will handle this slightly different, but I kind of like this approach. So we have another branch called develop. This is a branch that people can work on, merge their code into, use for testing, demonstrations, but it's still, and it'll always have all of the most recent changes. Say though, you have your main branch, which is the currently released version of whatever your project is. So what that means is, you started with main, you branched off onto develop, and people work off of develop. Say once a month on the 15th of every month, you release your project into the wild. So what that would then say entail is you merge your develop with all of its most recent code, features, bug fixes, whatever, back into main. The main is then tested and released. No work is done directly on main. Work is done on develop and in sub-branches of develop. So every now and again, develop is merged back into master or main. And this sort of happens every 15th of the month, like this. And how work happens is all your developers have master or develop checked out. And when a new work ticket, a bug, anything comes along, they pull their develop to make sure that it's as recent as possible. They then branch off that, do their bug fix, and oops, okay, and merge that back into develop. And with multiple people doing this, so this branch could be called like bug 1. Bug 1 gets fixed, tested. When they're happy that it's working and you follow whatever your company procedures are, maybe that's a pull request or I've been mauled. Yeah, a pull request, which means that other people in your team review your code before merging it in, or it's tested by an actual QA, whatever the case is. It then gets merged back into develop. And then this happens, this would happen multiple times a month for each new piece of work done. And then develop is merged back into Bang. And so this goes on in perpetuity. I hope that I'm explaining this in a reasonable way. I'm going to give a practical example now. But this is sort of how branches work. And I think a good general practice. But again, every company will do it slightly differently, and that's fine. It comes down to what works for the team. That's the most important thing. And sometimes the client. But hopefully the client isn't, too deep in your Git practices, because it's usually not relevant to them. So let's now jump into that practical example I've been talking about. Let's say we are Dev, James, and we're busy working on our Spring Boot project, and we get 2 tickets that come in. The first ticket says we must create a new model for people. So at the moment there's a node model. We need to be able to store people as well. So we need to create a new model for people. The second piece of work that comes in is to update the number of returned rows, nodes. I think at the moment that's 5. So how would I go about this? Well, I'd like to use the practice the sort of structure that I just described. So let's get started. We can get status, we're on main, we're up to date, everything's fine. What we want to do next is git checkout -b. So this creates, when you check out, you can either check out another branch, an existing branch, or if you do a -b, you create a new branch called what? Let's call it develop, like I just described. So we are now switched to new branch develop. So that this doesn't exist remotely at the moment, so I'm just going to git push this so stream origin event. Okay. So this will create a new branch which is merged is directly off master, called develop. This way, when a new user clones our project, say another fellow dev on our team, we'll talk to them. Your practices should be documented or at least discussed. We say we work off develop, we branch off develop, and say a team lead or whoever is doing releases merges the develop into master, does the tests and releases. So now if we refresh here, we should have a develop branch. So we can switch to that and view what's here, but at the moment it's exactly the same. So let's look at our tickets. First ticket, that's ticket 2, that's not our first ticket, is to create a new model for people. Okay, cool. So what do we want to do? First we want to, before, you don't want to work directly on develop, because again, that's a shared branch that multiple people use. So what we want to, but we do want to branch off it for our work. So we want to again create a new branch, and normally your tickets will have a unique identifier. So in Jira, that could be like the project code and then the ticket number. But this obviously doesn't have Jira, so we're just going to call it ticket 1. Git check out the ticket 1. Okay, cool. We don't really even need to push this remotely, and that might even normally would, but it doesn't matter. So right now we're working on a branch called ticket 1. That means there are essentially 3 copies of the code branching off each other in the structure I drew here, except instead of bug 1 here we're ticket 1. We haven't merged it back yet, so at the moment, you know, our diagram looks like this, and this is ticket 1 instead of bug 1. So let's do our ticket quickly. In Note, we want to make a new model. So I'm just going to copy paste like a real programmer. Load new file. Wanted to make a person. Cool. Class person. Yes. We can paste. Just call it person. This is all fine. Instead of it, we can keep the title and then full name. I'm not looking to do anything really complicated here. This is all fine. And an automatically generated ID, a title, and a full name. That's what we want. Steve constructor for person models. Okay, and then it says a title and a full. Cool, and we can just paste, oops, paste, title. I don't know what this is crying about. ID, title. Do we not even display? Oh, we do. Okay, cool. And then we have our get ID and our get title, and let's just generate new. I can't remember. Source actions. Generate getters and setters. We want full name. Getter and setter. Okay, cool. Sweet. So what we just did was we made a new file and we added some basic code for it. This is where some of the default functionality for Git within IDEs comes in. You can see this is green because code knows to look if you're in a Git repo and to add and update files accordingly. So we added this, it's green, that shows that it's, yes cat, a newly added file. What that means is, yeah, it's not committed yet, it's not part of a repo, it's nothing. So if we go git status, here we can see it's untracked, it's not part of the repo, so we need to add it. So we can just say git, oops, oh my goodness, not that. Git add, love it when she's just sitting on the mouse pad. So you can go directly to the file, it's safer. Oh my goodness. Source main. That's weird. Ls here. Ls. There's a main. Dot. What am I doing? Git status. Git add source main. This is very strange. This should be the path. This is my command line messing with me. If we do that, status, cool. So now this new file's been added. We haven't yet, it's staged to commit, but we haven't committed it yet. So if we do a git commit am again, created the new person model. Again, this is not pushed yet. This branch doesn't even exist remotely. Being annihilated by the cat again. And you want to just snooze. But this is now ready to push. For the purposes of this demo, rather than just push and merge this in, I'm going to do the other ticket before merging in. So, to better simulate 2 people. I wonder, do we want to have 2 sort of, right. So, we're committed. Our new file exists on our ticket 1 branch, but not on the develop branch. So let's get checkout develop. Okay. So now if we look at our project, you can see the person file doesn't exist here anymore because it's part of our ticket 1 branch, not part of our develop branch. Now let's imagine we're another developer who picked up the second ticket. James picked up the first one, someone else picked up the second one. I obviously only know one name. Let's say Carly picked up the second ticket. So we need to, Carly needs to update the number of return notes. So we want to make a new branch. Ticket, checkout, PHP, ticket 2. Oh, no, 2. Okay. We are now on ticket 2 branch, which is again based off dev. So right now there are 2 branches like this. You could say ticket 2. Cool. Okay, cat. At the moment, ticket 2 doesn't have any work on it. All that we needed to do was update the number of tickets returned. It didn't say how many. Let's say 2 cat over the keyboard to 6. So we want to open our NoteTaker controller. Here we have a constant for the page size. Let's update that to 6. So that was a change. If we now open our the cat is attacking a person. Do a git. Oh my word. I can't see what I'm typing, kitten. It's status over here. You can see there's a change to NoteTaker controller. We can do a git diff. You can see it changed from 5 to 6. And let's collect this bad boy. So we don't need to add the file because we didn't create any new files, but we do have to stage it. So that's the AM. Updated number of notes returned per page. Okay. Now, let's say while Carly was busy updating this page ticket, or busy working on this, James finished his his change to his new model. It's too late, but this is the first chance I've had. He added his new model to his ticket. It got approved and merged into master. So now let's check out ticket 1 branch. So we go here. This will be back to 5, and there's the person ticket. So what we would do now, we're on this branch. Okay, cat. We can do a git status. We can do a git. Oh, there will be nothing new, but this is a good set of hoops to jump through. We're not on a remote branch, so it's obviously going to pull anything. Right, I actually need to git checkout. So what we want to do now is called merging. We want to merge our changes from another branch into our active branch. Basically, ticket 1's done, signed off, it's ready to merge in so that other devs can now have access to the new model. So we want to git merge, and this always merge to your current branch, and then you say the other branch, ticket 1. So we are now status, one commit ahead of remote on develop, because we merged in the one commit from ticket 1 branch. So we're now on the develop branch, and we have a person. So what we've done is we've done this. I know it's called bug 1, but yeah. So if we do a git status, then we can push this. So now, if we look at develop, there's recent pushes. We don't need to PR because it's just me. Why do I want to PR? Oh, that would be if we wanted to merge develop back into main, but we aren't worried about that right now. However, if we look here, we can see here's our new file that we created, the model. So this is now on develop. And essentially we could delete our ticket 1 branch. But we won't. We won't right now. Now Carly is done, QAing her work. Check out -2. Note that you only do the -b when you want to make a new branch. If you want to check out an existing branch, you just have to type the name of the branch. So we can do a git status. You can see everything's working fine. If we go to code, we see we do not have person on ticket 2 because we don't have the most recent changes. However, we do have 6 ticket nodes per page. So what we can do here is what we should do before doing anything else. That's what I did just now. Before sort of finalizing your work on a branch, make sure you merge in from the parent branch, so that it's seamless when merging it back. So what we're going to do is git merge develop. So this is going to take the most recent version of develop and pull it again into our active branch, which is ticket 2. Sweet. So this now pulled in our person code into our ticket 2. So what we essentially did now was this. We merged again into ticket 2. And what we now want to do is merge back into develop, so that develop has all of our, let's have a look here. That's all happening. So now we can check out develop, and we can git merge git 2. So we're now on develop. If we look at git status, oops, we are ahead by 2 commits. That would be the merge. It's the number of commits that were on the branch that we merged in. So the one would be merging develop into ticket 2, and then the other would be the creation of the first commit we did, which was updating the page size. So those are the 2 commits that the develop branch is now ahead of. The local develop branch is now ahead of the remote develop branch. So we did our git status, it shows we do that, and we do a git branch. Oh, now if we do git branch, you'll see there's the main develop and our 2 ticket branches. So let's do a git push. So let's go back to our ticket, our project. Let's go to develop. So here we merged branch develop into ticket 2. Which created that. But before that, we updated our controller. Yeah. So this is now up to date. It is 6 instead of 5. So right now, our develop has everything that we want. It is both the work from the 2 tickets, and life is good. And what we can then do, so now say it's release time. What we want to do, this would normally fall to whoever's in charge of releases. Most people wouldn't work on main or master. So let's check out main, and then we can merge our develop into our main. We can push this. And then if we go back, minutes ago. Cool. So now main let's update our diagram again. Well, no, we don't need to. That's this line here. We're going back into main. So main is now at this point. It's up to date with all of our tickets, the latest code, and ready for release. And that is sort of the idea of Git, of branches, of version control, and separate working versions. So 2 different devs could work on on the same code without stepping on each other's toes. Keep everything up to date, avoid conflicts with files, and it's brilliant. And honestly, as a dev, you can't get by without it. Now, it's not always so seamless and happy. I'm going to show you another example now. Let's say, for argument's sake, 2 devs worked in the same file. Possibly like in the same parts of the same file. Git is quite clever, and it tries to merge in code intelligently, and it can often do it. But if you did both work on the same line, it's not like it's just going to magically choose one to go with. That would be, not the best. So that's where merge conflicts come in. I'm going to show you those now. Let's try an example. So let's just reuse our ticket branches. Ticket 1. So back on ticket 1, let's git merge develop in status. Okay. So now ticket 1 is up to date with ticket 2. They both have now branched off again. But you wouldn't normally reuse the branches. Once you merge them back into develop, you can delete those branches, and you would create new branches for whatever new bugs or issues came up. But let's just reuse them for the sake of this tutorial. Let's say, for whatever reason, I want to now change. So someone working on this branch wants to change the page size to 7. So he does that. Status. So how do you spell status? So we're on ticket 1. We've updated node taker controller. We're gonna commit sham further increased page size to 7. Cool. We're not gonna merge that into anywhere though. At the same time, how do I spell checkout tickets? Oh my goodness, 2. Okay. At the same time, someone was working here. Let's say they updated one of the functions. So for our page, they added a comment. This is a test comment. That's not all they did though. They also updated the page size to 8. No, to 10. Because people really just wanted huge pages. So what do we do now? What do we see? So diff shows us 2 changes, 6 to 10, and test comment. So we're now on ticket 2 branch. We know that on ticket 1 branch there's an update here. But in a team of remote people or even local people, you're not always aware who's working on what. So Dev Carly doesn't know that Dev James is messing with the page size. And let's say there was a miscommunication. They both thought that they would do that ticket, and for some reason they both updated it to a different size. But in addition to updating the size, Dev Carly also added a comment or changed one of the functions further down. So let's do Okay, these are committed, but nothing is pushed. So now Carly took a bit longer because she was also adding a comment. So if we check out our develop branch, status, and we merge in our ticket 1 branch. This is now 7. Right. So develop is now up to date once again. Ticket 1's branch is James, because James was faster on the gun than Carly. So develop now has changes to this file in the same places that ticket 2 has changes to this file. Get doesn't know which is the right one. So what happens now if we try to merge develop into ticket 2? Because that's what we should do before merging ticket 2 back into develop. So let's get status. We can push our develop ticket into the sky. Let's out ticket 2. And now we're done with our work, and we want to merge develop in before merging back into develop. Merge develop. Okay, so this is what we expected to see. Auto merging. It tries to merge by itself, but there was a conflict. Merge conflict in the Deca controller. Automatic merge failed. Fix the conflicts and commit themselves. So you're going to see here, if you status now, there are unmerged paths. We need to add them when we've resolved the conflicts. So code does some things. You can see this line was merged in no problem. It just added it in because there were no conflicts there. The other ticket 1 didn't change this function at all. This line stayed the same, so it has no issue here. But this line we both worked on. You can see in head, which is your current your changes in your current ticket, versus develop, which is where we're trying to merge in from. We changed it to 10, and it was updated to 7 on develop. We then confer with our requirements. We see no, it is definitely supposed to be 10. So then all that we do, we choose. You basically choose. This is your changes. This is the remote changes. We say no, we want it to be 10, so we can just delete that. Now a lot of IDEs have functionality to kind of override or do whatever, but I like to manually just delete and make sure that I have the right code. There are no other merge conflicts. Life is good. So what we can do now is get add source. This is going to do this again, isn't it? Okay, I'm just going to mark. Alright, all conflicts are fixed, but we're still merging, so we can do a git commit. Get the message. See, you must always add a message. So this is not upset anymore. The file, our changes were merged in. The conflict was resolved, and life was good. Conflicts will often be more complicated than that. Obviously, if you're working on functional code, it's a bit different to merging, a line that says 8 or 10. But usually, it's clever enough to merge in most stuff, and only if you both worked on exactly the same thing, you'll have issues. And usually, that you shouldn't be doing that. So now, get status. How are we? We're still on ticket 2, we want to merge it into develop. So if we get, check out develop, let's merge ticket 2. So now we're on develop, our active development branch. That's the base for all of our tickets to branch off of. Our page size is 10. We have our test comment. We have our person. And all of our work is here up to date, which is exactly what we wanted. We basically are where this diagram is. We just did an extra sort of merge in there, and then another pull and merge in here. right now develop as a head of main, but that's okay. So we merged in. Let's say we did a release over here, and now we're in the next month busy doing work, and when it's time to release, we'll merge develop back into main and do a release from there. And that's what you just saw there, is kind of Git 101. You clone repos, you create relevant branches, generally along a company standard. I like having a develop branch, but every company will do this a bit differently. I like branches for each dev, which some people just consider way overkill, and then inside that for each ticket, but it's not really necessary. You can just work off develop and branch off tickets. That's actually, I think that's the best way to go these days. It's just I've worked at places before where people have somehow consistently overwritten their work, and having another layer between your branches and your master gets around that. They were really terrible. I don't know how people managed to do some of the things they do. Then just a few little side things before I call this. Your ignore file. This is important and cool. Basically, you can add a .gitignore file. This is a hidden file, depending on your file system, that you use to tell Git to not commit certain files. This is very relevant for compiled files. So in Java, your class files, for instance. They're built when you compile a project, and you don't want them to be committed, because every time someone rebuilds on their side, they are going to get merge issues. The merge issues are going to be actually impossible to resolve because it's not really human readable. And you don't need to have those locally, because part of just generating the project is creating them. In Swift, you probably don't want to, you'd probably want to ignore your pods. You'd include your pod file, but you wouldn't include your pods, because why? It's just unnecessary. When you clone the project, you can install your pods locally. They just take up, it's like libraries. You know, as long as you can install them, you don't need to include them. Here we have like these, the build plugins and things. You have the POM file, which tells Maven what to do, but you don't need to include the libraries themselves in the repo. It's just unnecessary. So by editing your Git file, you can tell Git don't include .ipr, IML, IWS, or IDEA files. These are to do with IntelliJ. Here's code. Don't include a .vs folder. Presumably that has a bunch of project-specific settings in it, which maybe your teammates shouldn't have, because they'll create their own, project setup, and that would just mean constant conflicts and be a total pain in the ass. Git is quite cool in that when you, or GitHub, I think they all probably do this these days, but essentially when you create a new repo, you can say add a git ignore, and you can choose what type of project it is, and then you get a template with, so let's say it's a Swift project, Xcode, okay, whatever, iOS, well, there are a lot of templates, and you can Google more, and it's super handy, because maybe off the top of your head you aren't aware of all of this, so that just does it for you. But you can just fully do this yourself, and you can always add more. So say I work on a Mac, and I'm a bit sick of DS store files being pushed because my Windows users don't want them. Mac jank, and I can say .ds store file folders, because Windows people don't want them, and they're also different for each Mac. Your Git file is committed the same way as any other file, so you can see there my Git file has been modified. I can update it, change it, whatever, and but you don't actually need to change it, or you don't need to commit it for you get to start ignoring the new things that you add to it. It's not super relevant, but a small note. So I like that. Yeah, really important. Don't forget about your ignore files. And also, yeah, like I said, GitHub's really nice in that you have. So maybe Xcode, Swift. Yeah, there's Swift. Okay, cool. Yeah, you can. I'm sure you can Google other templates, but this will usually cover your basics, and you can, like I showed you, was that more. Then another quick command, which I find super useful, and this is actually a reasonable time to do it. Let's now say, what are we on? Branch. We're on develop. Let's say so what will happen now if I check out another branch? Check out ticket one. Right. We didn't commit our changes, which means that our uncommitted changes are moved over to the new branch. So we can now say commit git make oh, what am I doing? It is late. Updated we say ignore file to Mac check. I didn't have a closing quote there. Oh well. So, and then we push this, and then in review, someone's like, wait, no, I want my DS store files. Don't do that. Don't ignore them. They're an important part of my project. So then you are like, I can just remove this and commit it. But let's, for argument's sake, say that this was a more complicated file. And what we actually want to do is now revert our commit. So we want to, well, not revert a commit. You can revert a commit, you can go back to a certain point, but I think that's out of the scope of this 101. But what is a really handy function, if you just want to check out a file from a separate branch to the state of the separate branch, is this. You can do a git checkout, then the other branch's name. So we want to get the develop ignore file back. Dash. Yes. So now if we get status. So it's a change, obviously, to our local branch, but what we have is the get ignore file from the develop branch. This command can be a lifesaver in a pinch, so I recommend hanging on to that. And then we can check out. Yeah, so that's a handy command. Let's get ignore, and that's all of the basics. So let's recap. What we did at the start. We cloned our repo. We looked at making a small change, committing it locally, and then pushing it. We looked at how work might come in tickets and how you would create branches for each ticket. How multiple people might be working off the same branch, but off the same branch, but on their own working branches, and how you would pull your develop branch, whatever that might be called in your company, into your active branch before merging your branch back into develop. And we looked at how you might get conflicts between team members, merge conflicts, and then how you would resolve them. And then, yeah, just those little tips with the ignore file and that last command, which I'm a big fan of. And that sums up basically what I wanted to cover with this. In my opinion, that's version control 101 with Git, and that's all you really need to get started. I did this on the Spring project, but it would apply to any project. I just did that because that's what I had from the last learning stream. And yeah, thank you to anyone who watches this. I hope it helps someone. If not, I had fun planning out the lesson, and I'm looking forward to doing more. So I hope you all look after yourselves. Stay well. The cat is now fast asleep on my lap, obviously. Um, and yeah, stay well. Look after yourselves. Learn something new. Cheers.